Kubernetes can look simple in a quick demo. One app, one pod, one command. But real delivery is not that simple. A real application needs a way to keep the right number of replicas running. It needs a stable way to receive traffic. It needs external URLs. It needs permission boundaries. It needs traffic control. It needs secret handling. And it needs health checks so bad instances do not quietly stay in rotation. That is why Kubernetes is not one object. It is a set of control objects that work together around desired state. In this video, I will explain the most important ones clearly: deployments, services, Ingress, RBAC, network policies, secrets, and liveness and readiness probes. First, I will show the top-level delivery picture so the parts make sense before we zoom in. Then we will break down workload control with deployments, replica sets, rolling updates, rollbacks, and probes. After that, we will explain how services and Ingress expose an application from inside the cluster to outside users. Then we will cover permissions and traffic control with RBAC, service accounts, and network policies. Then we will talk about secrets and why plain Kubernetes secrets are not enough without encryption, RBAC, and external secret controls. And at the end, I will bring everything back together so you understand not only what each object is, but why teams actually use it. Start with the big picture. Kubernetes is a desired state system. That means you declare what you want the platform to keep true, and controllers keep pushing the live system toward that declared state. Imagine a web application. Users reach a public URL. That request usually lands at Ingress first. Ingress decides where that traffic should go based on host names, paths, and TLS settings. Ingress routes the request to a service. The service gives the app a stable network identity inside the cluster. Behind that service are pods. Those pods are usually created and managed by a deployment. Under the deployment, a replica set makes sure the correct number of pod replicas exists. Around that main traffic path, Kubernetes adds control layers. RBAC controls who or what is allowed to do what. Network policies control which pods are allowed to talk to which other pods or external destinations. Secrets hold sensitive configuration, but they must be protected carefully. And probes decide whether a pod is healthy enough to stay alive and ready enough to receive traffic. So if you remember one thing early, remember this. Deployments control desired application state. Services and Ingress control reachability. RBAC and network policies control risk. Secrets control sensitive data. And probes protect runtime health. Now let us zoom into deployments and replica sets. A deployment is the high-level workload object most teams use for long-running, stateless applications. What is it for? It is for saying, I want this application running with this container image, this configuration, and this replica count. Why do teams use it? Because they want Kubernetes to keep that state true over time, even when pods fail, versions change, or replicas need to grow or shrink. A deployment does not create pods directly. It manages a replica set. A replica set is the lower-level object that keeps the requested number of pod replicas running. If one pod dies and the desired count is still 3, the replica set creates another one. That is the reason replica sets exist. They maintain replica count. Then why use a deployment on top of that? Because a deployment adds rollout logic. It can create a new replica set for a new version and gradually move traffic from old pods to new pods. That is a rolling update. A rolling update lets a team replace application instances step by step instead of stopping everything at once. That reduces downtime and makes release risk easier to manage. And if the new rollout causes problems, a deployment can roll back to an earlier replica set revision. That is why rollback matters. It gives the team a quicker path back to a known working state. Now add probes. Liveness probes answer this question. Should this container still be alive, or is it stuck badly enough that Kubernetes should restart it? Readiness probes answer a different question. Is this pod ready to receive traffic right now? That difference matters. An app can be alive but not ready. If readiness is false, Kubernetes should keep the pod out of the service endpoint list. If liveness keeps failing, Kubernetes should restart the container. Teams use probes because a deployment is not only about starting containers. It is about starting healthy, ready, usable instances. Now let us talk about services and Ingress. A pod is not a good stable network target for application clients. Pods can restart, IPs can change, replica counts can change. That is why Kubernetes uses services. A service gives a group of pods one stable name and virtual IP. What is a service for? It is for exposing a set of matching pods behind one consistent network identity. Why do teams use it? Because other parts of the cluster need a stable way to reach the app without caring which pod instance is currently alive. If a deployment has 5 pods, the service can load balance across them. So the service acts like a stable front door inside the cluster. Then what is Ingress for? Ingress is for external HTTP and HTTPS routing. It lets teams define which public hostname or URL path should route to which service. For example, app.example.com might go to the web service, while api.example.com goes to the API service, or /shop might route to one backend, or /admin routes to another. Ingress often also handles TLS termination. That means HTTPS can be decrypted at the Ingress layer before traffic is forwarded deeper into the cluster. Why is that useful? Because it centralizes certificate handling and routing policy instead of making every application pod solve that itself. So the top-level exposure path usually looks like this: external user, then Ingress, then service, then pods. That is the reason services and Ingress are separate. A service solves stable internal reachability. Ingress solves controlled external routing. Now let us move to access control. RBAC means role-based access control. What is RBAC for? It is for deciding who or what can read, create, update, delete, or watch Kubernetes resources. A role or cluster role defines allowed actions. A role binding or cluster role binding attaches those permissions to a user, group, or service account. Why do teams use RBAC? Because not every workload, engineer, or automation system should have broad cluster power. Permissions should be deliberate and narrow. A service account is the identity a pod can use when it talks to the Kubernetes API. That matters because workloads often need some API access, but they should not automatically get admin-level power. For example, one pod may only need to read config maps in its namespace. Another controller may need broader access across many objects. RBAC lets teams express that difference. Now look at network policies. What are they for? They are for controlling allowed traffic between pods, namespaces, and sometimes external destinations, depending on the network plugin in use. Why do teams use them? Because default cluster networking is often too open for serious production environments. Without policy, many pods may be able to talk to many other pods by default. That can widen blast radius during a compromise or misconfiguration. A network policy can say things like, only pods with this label can talk to the database. only the Ingress controller can reach the front-end pods. These pods can call this external service, but not the public internet in general. So RBAC controls API permissions. Network policies control network reachability. Those are different layers, and teams need both. Now let us talk about secrets. A Kubernetes secret is an object that stores sensitive values such as passwords, API tokens, certificates, or access keys. What is it for? It is for separating sensitive configuration from normal application configuration. Why do teams use it? Because secrets should not be treated like ordinary settings. But here is the warning. A Kubernetes secret is not automatically strong security just because it is named secret. If secrets are only base 64 encoded, they are merely obscured, not truly protected. That is why teams care about 3 extra controls. First, encryption at rest. If the cluster data store is compromised, encrypted secrets are safer than plain stored values. Second, RBAC. Only tightly approved identities should be allowed to read or manage secrets. Third, external secret store controls. Many production teams use systems like Vault, Cloud Secret Managers, External Secrets Operator, or similar tools so Kubernetes does not become the long-term source of truth for every secret value. This matters because sensitive data deserves lifecycle control, audit, rotation, and narrower exposure. And now tie this back to probes and safe delivery. A deployment can look successful while the app is still failing at runtime. A service can expose pods that should not yet receive traffic. Ingress can route beautifully to an unhealthy backend. RBAC can be too broad. Network policies can be too open. Secrets can be handled badly. That is why Kubernetes objects are not magic. They are control tools. Teams still need disciplined design, review, testing, monitoring, and least privilege. So here is the simple mental model. Deployments describe the application state you want to keep true. Replica sets keep the requested number of pods alive. Rolling updates and rollback help teams change versions more safely. Liveness and readiness probes protect runtime health and traffic readiness. Services give pods a stable internal front door. Ingress gives users controlled external URLs, TLS termination, and routing. RBAC and service accounts control API permissions. Network policies control which workloads can talk to which other workloads or outside destinations. Secrets hold sensitive data, but they still need encryption, RBAC, and external secret store discipline. If you understand those ideas, Kubernetes stops looking like a random list of YAML kinds and starts looking like a delivery system with clear responsibilities. That is what all of this is about. Each object exists because teams need control over state, traffic, access, risk, and health. If you want, next I can break down these same Kubernetes objects with one full app example from deployment to public URL.